Good morning everyone, and thank you for joining this session. Today I'd like to introduce you to the EnTRAINER project, a 3-year initiative funded under the Life 21 CET program. EnTRAINER focuses on one of the most critical and challenging fields in the energy transition, energy-intensive industries. These are sectors that operate at high energy demand, and therefore carry a huge potential for meaningful decarbonization, but also face the greatest practical and economic barriers. To understand the scale of EnTRAINER, it's important to look at what the project is actually doing on the ground. The first major activity is the implementation of 80 energy scans across industrial sites in the 4 participating countries. These scans are essentially rapid assessments designed to identify opportunities for improvement and determine whether a site is ready to move on to a full ETA. A key feature of this work is that it follows a multi-sectoral approach. The project doesn't focus on a single type of industry but instead engages with a broad range of sectors, large energy-intensive industries as well as small and medium-sized enterprises. This diversity helps us refine the tools, identify common challenges, and understand sector-specific needs. From those initial 80 sites, 40 industrial facilities will go through the complete process of an energy transition audit and the development of a full decarbonization action plan. These ETAs represent the heart of the project. They are where technical analysis meets organizational strategy, and where the shift from energy efficiency to decarbonization planning becomes concrete. Throughout these activities, EnTRAINER aims to create replicable good practices, encourage cross-country knowledge exchange, and support industries in embracing the transition to a low-carbon future, not as a regulatory burden, but as a strategic opportunity. One of the most important pillars of the project is capacity building. EnTRAINER doesn't just produce audits, it works to strengthen the skills and knowledge of the people who will actually implement decarbonization strategies. For this reason, the project designs and delivers 2 types of accredited training courses in each partner country. First, a 5 ECTS course aimed at current and future energy professionals, helping them gain a deeper understanding of energy transition processes. And second, a 2 ECTS course tailored specifically for practicing energy auditors, expanding their skill set beyond traditional auditing and into decarbonization planning. In addition, companies themselves receive short, targeted trainings for their staff. This ensures that the people working inside industrial facilities, operators, engineers, energy managers, are equipped to understand and support the changes recommended in their decarbonization action plans. At the center of all this lies the Energy Transition Audit, or ETA. This is not just an improved audit, it's a fundamentally different approach. An ETA looks at the technical aspects of energy use, of course, but it also considers organizational culture, financial planning, emissions pathways, and the broader business strategy. Most importantly, the ETA leads directly to a decarbonization action plan, which outlines clear steps, both short-term and long-term, toward reducing emissions, integrating new technologies, and preparing the organization for the challenges of the next decades. Finally, the ETA acknowledges the importance of non-energy benefits, things like improved safety, productivity, product quality, or staff satisfaction. These benefits often motivate companies more than energy savings alone, and integrating them into the analysis helps build stronger engagement and commitment. Altogether, these elements, training, ETAs, DAPs, and NEBs, form the core structure of the EnTRAINER approach. To appreciate the scale and impact of EnTRAINER, it helps to look at the numbers behind the project. First, we have 8 editions of accredited training courses delivered across the partner countries. Through these courses, we have already trained 880 professionals, equipping them with the knowledge and tools required for energy efficiency and energy transition in the industrial sector. This means the project is building not just solutions, but also the workforce capable of sustaining those solutions in the long term. Next, the project has completed 80 energy scans in energy-intensive industries, allowing us to understand real industrial needs, maturity levels, and potential pathways for decarbonization. From these, 40 sites were selected for full energy transition audits. These ETAs will become flagship examples demonstrating how industries of different sizes and sectors can plan and execute decarbonization actions. Another major achievement is the development of 4 new online tools, freely available to professionals, trainees, and companies. These tools support auditing activities, energy monitoring, heat loss calculations, and basic assessments of efficiency opportunities. The project has also created a training platform and knowledge hub, enabling ongoing interaction, knowledge sharing, and collaboration among participants and stakeholders even after formal courses end. Beyond direct project outputs, EnTRAINER also triggers 40 additional indirect ETAs through its engagement with external auditors and stakeholders. In parallel, 400 company staff members, including key decision makers, are being trained and sensitized to energy transition topics. Ultimately, the project is expected to contribute to 4.75 GWh of primary energy savings, 5.16 GWh of renewable energy generation, and a reduction of approximately 800 tons of CO2 equivalent emissions. These numbers are not simply project KPIs, they reflect real and measurable progress toward Europe's industrial decarbonization goals, showing that EnTRAINER is delivering tangible impact on the ground. This slide highlights the central concept of EnTRAINER, the energy transition audit. Traditional energy audits tend to focus on improving efficiency within existing processes. They often provide a list of measures to save energy or reduce costs, but they rarely address long-term strategic transformation. In contrast, an energy transition audit takes a much broader approach. A key component of the ETA methodology is collective involvement and collaboration. Decarbonization cannot be achieved by energy managers alone. There must be participation from multiple departments, levels of staff, and decision makers. The ETA framework encourages active participation. People are not just informed, they are engaged, asked for input, and included in discussions. Open communication, transparent conversations among teams help break silos and ensure that everyone understands the goals and challenges. Inclusive decision-making, a diverse set of voices is included, from technical personnel and engineers to financial teams and top management. This collective approach brings clear benefits. It taps into a wider base of knowledge within the company. It leads to more creative and innovative solutions because people with different backgrounds contribute to the discussion. And importantly, it creates a sense of ownership. When employees feel involved, they are far more likely to support and carry out the changes needed for decarbonization. In this way, the ETA becomes more than a technical audit, it becomes a process of empowerment, alignment, and strategic planning. Continuing with the core concept of ETAs, the slide emphasizes why this approach is so central to EnTRAINER's vision. Energy transition audits represent a shift from short-term thinking to a long-term decarbonization mindset. They help companies understand not only what measures they can implement today, but also how to position themselves strategically for the next 10, 20, or even 30 years. ETAs integrate multiple components: technical assessment, examining equipment, processes, and energy flows; strategic planning, defining decarbonization targets aligned with European frameworks like the Green Deal, Fit for 55, and national climate laws; financial evaluation, ensuring that proposed measures make sense economically and are compatible with available funding schemes; non-energy benefits, which add value beyond energy savings, benefits such as improved safety, reduced maintenance, higher product quality, or enhanced competitiveness. Another key element is that ETAs involve a structured and cooperative process. Companies do not simply receive recommendations, they take part in shaping them. This shared approach improves commitment and makes it easier to implement changes later. Ultimately, energy transition audits form the backbone of the EnTRAINER project because they create a direct bridge between assessment and action. Instead of stopping at an evaluation report, the ETA leads to a customized decarbonization action plan, making it a practical tool for transforming industrial sites and preparing them for a low-carbon future. Now let's look at the progress made so far with the implementation of energy transition audits across the participating countries. EnTRAINER has already carried out ETAs in 20 energy-intensive industrial sites distributed across Greece, Italy, Romania, and Spain. These are companies from diverse sectors: metallurgy, ceramics, chemicals, artificial wood production, and other heavy industries, each with unique operational challenges and energy profiles. The ETA process begins with a baseline GHG inventory, covering Scope 1 and Scope 2 emissions. This is the foundation of the decarbonization planning because it establishes a clear understanding of where emissions come from and which operations are responsible for the biggest share of the carbon footprint. From this baseline, the ETA team works with each company to develop a tailored decarbonization action plan, a DAP. This is not a generic document, it's a structured roadmap that includes short, medium, and long-term actions. It also identifies which measures can be implemented immediately and which may require technological advancements or more substantial investment. These DAPs are practical, aligned with the company's capabilities, and designed to support real implementation rather than theoretical goals. Through this methodical approach, each industrial site receives a clear, strategic pathway toward decarbonization. Across the 20 audited industrial sites, the standardized baseline inventory came to 327,000 tons of CO2 equivalent. This is a very significant emissions baseline and shows how critical the industrial sector is when it comes to Europe's climate commitments. One of the most important insights is that around 90% of emissions come from heavy industry. These include sectors such as iron production, ceramics, chemicals, and artificial wood manufacturing. These industries are extremely energy-intensive, often rely heavily on natural gas, and face many structural barriers in transitioning to low-carbon processes. The project also found that the EnTRAINER tools, developed specifically to streamline data collection, played a major role in improving efficiency and accuracy. These tools helped companies organize their data, understand their energy flows, and identify gaps that might otherwise go unnoticed. In summary, the work completed so far has given us a much clearer understanding of the real emissions landscape in these industries, enabling us to design more targeted and realistic decarbonization pathways. This slide focuses on the results and insights collected from companies that have already gone through the ETA process. First, there has been very strong interest from industries in participating. Many companies recognize that decarbonization is becoming a strategic priority, not only for regulatory compliance, but also for competitiveness and cost stability. The project teams also conducted several one-on-one sessions with companies, which significantly improved engagement. These direct interactions helped build trust and made it easier to discuss sensitive topics such as energy consumption data, long-term planning, and investment decisions. However, it wasn't without challenges. Some companies showed reluctance during administrative steps, especially around signing NDAs. This is a known barrier in many auditing projects, as companies may worry about confidentiality or commercial sensitivity. Despite this, most sites eventually proceeded once the purpose and safeguards were clearly communicated. Another key insight is that companies tend to focus on technical measures with strong financial and technical feasibility, in other words, solutions that are cost-effective and easy to implement. While this is understandable, it sometimes means that transformative measures, which require longer-term investment, are viewed as less attractive. Regarding targets, most companies align with EU climate objectives. Net zero emissions by 2050, and around 60% emissions reduction by 2030, in line with Fit for 55 and REPowerEU. Among the 20 audited sites, 11 aimed for deep decarbonization, targeting 100% emissions reduction. However, 6 companies adjusted their goals to below 80%, typically due to high investment costs, limited technological readiness, or uncertainties in the supply chain. These findings highlight both the ambition and the practical constraints industries face. They show that ETAs can guide companies toward realistic yet ambitious decarbonization strategies, even when barriers exist. A key part of the EnTRAINER project is the development of 4 specialized online tools designed to support both auditors and industrial companies during the ETA process. These tools make the entire workflow, from data gathering to on-site assessment, much faster, more accurate, and more standardized. The first tool is the QSUM Control tool. This tool provides real-time supervision of a site's energy consumption. It uses cumulative sum analysis to detect anomalies or unusual energy behaviors that deviate from the baseline pattern. In practice, this means companies can quickly spot abnormal consumption, equipment malfunctions, or operational inefficiencies. The second tool is the heat loss calculator. It offers a quick estimation of the building's thermal insulation performance, something that is often overlooked in industrial settings. This tool helps companies identify potential issues with heat losses from roofs, walls, or windows, which can lead to significant wasted energy over time. Next, we have the Online Energy Audit Estimator. This tool is designed to provide a simplified but reliable estimation of the energy efficiency potential of a facility. It uses a series of structured questions about the building, equipment, and operational characteristics to give companies an indication of what kind of savings they might expect from different efficiency measures. And finally, the On-Site Auditor tool. This is like a digital assistant for auditors. It streamlines the data collection during the on-site survey and automatically generates certain parts of the final audit report. It greatly reduces administrative workload and helps ensure that all critical parameters are recorded in a structured, comparable format. Together, these four tools form a powerful support package for both ETA implementation and training. They increase transparency, accuracy, and speed, making the entire auditing process more efficient and accessible. This slide introduces a real case study from one of the companies participating in the EnTRAINER project. This particular site operates in the manufacturing sector, producing porcelain and ceramic products. Ceramic and porcelain industries are typically very energy-intensive because they rely heavily on thermal processes such as drying and kiln operations, which traditionally use natural gas. This makes them ideal candidates for exploring electrification, renewable integration, and efficiency improvements. For this company, the ETA established two key targets: an intermediate target of reducing emissions by 68% by the year 2030, and a final target of full decarbonization by 2050. These targets are ambitious but achievable when supported by a structured decarbonization action plan. The ETA for this company identified a balanced mix of technological measures, electrification options, and renewable energy integration. This case study demonstrates how ETAs can guide energy-intensive industries, even those with complex thermal processes, toward meaningful, long-term emissions reductions. Building on the previous slide, this one highlights examples of the measures identified for the case study company. These measures span the full hierarchy of decarbonization actions, from renewable integration all the way to process optimization. Level 1 measures include installing a photovoltaic system and integrating a battery storage system. These solutions help the company increase self-consumption of renewable energy and improve resilience against price fluctuations in the electricity market. Level 2 measures relate to electrification, specifically the introduction of heat pumps and the adoption of electric vehicles for on-site transport. Electrification is essential for long-term decarbonization, especially in industries that currently rely heavily on fossil fuels. Level 4 measures focus on efficiency upgrades. These include retrofitting the lighting system, installing variable speed drives, renewing agitators, and, very importantly, replacing gas-powered ovens with electric ones as the technology becomes more mature. These measures reduce energy demand and prepare the company for deeper electrification steps. Level 5 measures target system-level optimization, such as reducing compressed air losses, which can lead to substantial energy savings with relatively low investment. Together, these measures form a comprehensive set of actions, each contributing to the company's long-term decarbonization journey. This example illustrates how ETAs provide practical, technically sound pathways toward carbon neutrality, even in hard-to-abate industrial sectors. Now that we've seen how the energy transition audits are applied in practice, let's look at some overall conclusions from the analyses so far. One of the most striking findings comes from the emission inventories. On average, Scope 1 emissions account for around 89% of total emissions in the studied industries. These are the direct emissions from on-site fuel combustion, especially natural gas used for thermal processes like heating, drying, or melting. This shows that decarbonizing industrial heat is one of the biggest challenges facing these sectors. When it comes to decarbonization action plans, or DAPs, companies tend to start with measures that improve energy efficiency, things like process optimization, motor control, or waste heat recovery. These are often the most cost-effective first steps and can deliver quick results. After that, the focus gradually shifts to electrification of processes and integration of renewable energy sources, either on-site or through green electricity contracts. However, electrification brings its own challenges. Many technologies, like high-temperature electric ovens or large-scale industrial heat pumps, are still emerging and not yet fully proven at scale. On top of that, electrification can dramatically increase the company's electricity demand, creating the need for grid upgrades, storage solutions, and new operational strategies. Another important issue is electricity sourcing. Even when part of the electricity is covered by on-site renewables, companies often still rely on grid electricity. To maintain decarbonization credibility, many are turning to green contracts or power purchase agreements, PPAs, to ensure that the electricity they buy is truly renewable. In summary, the EnTRAINER project shows that decarbonization is achievable, but it requires a combination of efficiency, electrification, and smart energy sourcing, all aligned with each company's specific context and capabilities. Of course, implementing energy transition audits and decarbonization action plans is not without its challenges. One of the most common issues we face relates to photovoltaic (PV) installations. In many regions, industries encounter grid bottlenecks or capacity limitations that prevent them from connecting new PV systems, even when the technology and finances are in place. Additionally, each country has its own regulatory schemes, net metering, net billing, feed-in tariffs, and other support mechanisms, which can make project planning complicated and sometimes discourage investment. Another barrier is that PV plus storage systems, which could dramatically increase self-sufficiency and grid flexibility, are not universally supported by regulation. Many incentive schemes focus only on generation, not storage, leaving companies without sufficient motivation to adopt integrated systems that would actually provide more benefits to the grid. Fuel switching is also a major challenge. Moving from fossil fuels to cleaner alternatives, such as hydrogen or biomass, often requires high capital investment and long payback periods. Moreover, there is a lack of a clear and stable policy framework in many countries to support these transitions. Finally, local regulations can either act as barriers or enablers. In some cases, strict permitting procedures, slow bureaucracy, or conflicting rules between local and national authorities delay projects. In others, progressive regional policies, like those promoting green PPAs, can accelerate decarbonization efforts. These regulatory and technical hurdles highlight the need for coherent national and EU-level policy frameworks that make it easier for industries to invest in decarbonization technologies confidently and without unnecessary risk. Beyond the technical and regulatory challenges, another important issue is the assessment of non-energy benefits, or NEBs. Non-energy benefits refer to all the positive outcomes that go beyond pure energy savings, things like improved air quality, reduced maintenance costs, safer working environments, better product quality, or a stronger company image. These benefits can significantly enhance a project's value, yet they're often overlooked because they are harder to measure. One major barrier is the lack of standardized methodologies for identifying and quantifying NEBs. Auditors and companies often don't have a consistent framework to calculate their impact, which makes it difficult to include them in financial or policy evaluations. We are currently waiting for the new Senelec standard to provide clearer guidance in this area. There are also data challenges. Many companies struggle to collect accurate information or to establish baselines for non-energy aspects such as maintenance frequency or product quality. This makes comparisons and progress tracking more complicated. Additionally, limited awareness and skills among both auditors and company staff often mean NEBs are not recognized or documented during audits. Even when identified, companies may find it hard to assign them a monetary value, and therefore underestimate their strategic importance. Despite these difficulties, the EnTRAINER project has already identified the top 10 NEBs commonly observed across the 4 participating countries. These include contribution to the company's long-term vision and sustainability strategy, reduction of pollutant emissions such as CO, CO2, NO, and SO, lower exposure to energy price risks, improved public image and competitiveness, better equipment performance and reliability, regulatory compliance and readiness for future environmental standards, development of green products and services, and reduced maintenance costs. Recognizing these broader benefits helps industries see decarbonization not just as a compliance task, but as a strategic opportunity to improve performance, reputation, and long-term resilience. In addition to the technical and regulatory barriers we've discussed, there's another kind of challenge that often proves even more difficult to overcome, and that's the cultural barrier. Many companies still view energy efficiency and decarbonization as purely technical or cost-saving issues rather than as strategic priorities. The mindset is often, if it doesn't pay back in 2 years, we're not interested. This short-term approach can seriously limit ambition and delay meaningful transformation. Furthermore, in many organizations, employee engagement on energy issues remains low. Operators, technicians, and even middle management may not feel personally connected to the company's energy goals. Without awareness and participation from all levels, valuable opportunities for savings and innovation often go unnoticed. There is also a natural resistance to change that affects most organizations. Implementing new technologies or altering long-established processes can seem risky or inconvenient. This resistance can be particularly strong in traditional industries where processes have been stable for decades. The lesson here is clear: technical solutions alone are not enough. For real progress, companies must embed energy efficiency and decarbonization into their corporate culture. This means setting medium and long-term targets that go beyond compliance, recognizing energy performance as a key component of business excellence, and promoting energy awareness across all departments. Changing company culture takes time, but it's one of the most powerful and lasting ways to ensure that the results of energy transition audits are not only achieved but also sustained over the years. This brings us to one of the most inspiring aspects of the EnTRAINER project: the idea that energy efficiency is not just about technology, it's about people. No matter how advanced our tools and audits become, success ultimately depends on the individuals who operate, maintain, and manage industrial systems every day. If they understand the goals and feel empowered to contribute, transformation becomes much easier. That's why EnTRAINER puts such a strong emphasis on training and upskilling at every level of the organization. By equipping people with the right skills, knowledge, and motivation, we can foster a true culture of energy consciousness, one where every employee sees energy efficiency as part of their daily responsibility. When staff are empowered, they don't just follow instructions, they actively identify and implement improvements. They become problem solvers, innovators, and advocates for sustainability within their companies. This shared sense of ownership leads to better results and deeper commitment. So, while the technology provides the tools, it's the people who provide the drive. The EnTRAINER approach recognizes this human element as fundamental to achieving long-term decarbonization in industry. To put this philosophy into action, the EnTRAINER project has developed a comprehensive training strategy that targets all the key actors in the energy transition. The project delivers 3 types of training courses. First, a 5 ECTS academic course for current and future energy professionals. This course equips students and engineers with advanced knowledge of energy transition audits and decarbonization action plans. Second, a 2 ECTS course for practicing energy auditors, helping them upgrade their skills from traditional auditing to the more holistic ETA methodology. And finally, a series of short in-house training sessions within companies, designed for staff at all organizational levels. These sessions focus on practical aspects of energy efficiency, process optimization, and implementing decarbonization action plans. All courses are academically accredited with ECTS credits, and some have also achieved professional accreditation, making them valuable for career development as well as project implementation. the response has been overwhelmingly positive. The project initially aimed to train 880 people, but participation has already exceeded expectations, with more than 1,000 trainees expected by the end of the project. What's even more exciting is that EnTRAINER's influence has gone beyond Europe, attracting interest from professionals and institutions globally. This shows that the energy transition audit methodology resonates widely. It addresses a universal challenge: how to empower people and organizations to act on decarbonization in a structured, achievable, and human-centered way. In short, EnTRAINER doesn't just build tools or reports, it builds capacity, competence, and confidence in people. And that's the true foundation of a successful energy transition. Now that the project has reached an advanced stage, we've gathered valuable lessons from all the audits, trainings, and interactions with industrial partners. The first big takeaway is the power of visual and interactive tools. Companies respond much better when information is presented clearly, through graphs, dashboards, or visual roadmaps. These tools help them truly understand where they stand today and what specific actions are needed to reach CO2 reduction targets. When progress is visible, commitment grows. Another key lesson concerns monitoring and verification. Having the right digital systems, such as energy management systems, energy audits, and well-defined key performance indicators, is essential. These tools make it possible to track improvements, verify savings, and maintain accountability over time. We also discovered the importance of cross-departmental collaboration. Decarbonization efforts that involve not just the technical team but also finance, procurement, and management are far more successful. When all departments understand and contribute to the roadmap, the measures are implemented faster and more effectively. We learned that the decarbonization roadmap itself is a strategic tool, not just a list of actions. It supports long-term decision-making, helps companies prioritize investments, and links daily operations to their sustainability vision. Another insight is that funding availability influences priorities. Companies tend to implement measures that have access to grants or financing options, even when those measures aren't technically the most impactful. This shows how crucial it is to align technical planning with financial strategy. And finally, the ETA must always align with the company's strategy and legal obligations. When decarbonization becomes part of the company's vision, embedded into its governance and business plan, it stops being an optional exercise and becomes a natural part of decision-making. Altogether, these lessons confirm that energy transition is not just a technical journey, it's an organizational transformation that combines tools, collaboration, and leadership. As the EnTRAINER project approaches its conclusion at the end of 2025, our focus now shifts to the next phase, ensuring that the results, methods, and lessons are carried forward into future initiatives and policies. The project has proven that energy transition audits work. They engage people, deliver measurable results, and help industries move from theoretical goals to practical implementation. But the next challenge is to make sure these practices become standardized and mainstream across Europe. One of the key messages we'll be promoting in this final stage is that energy efficiency is not just about saving costs, it's a strategic asset. For too long, companies have seen efficiency as a financial metric, something you do to reduce bills. But the real transformation happens when businesses shift their mindset from save energy to cut costs to decarbonize to future-proof. This is the cultural leap we need to make. Reaching this new mindset requires strong leadership commitment, active employee engagement, and continuous improvement. Everyone, from the factory floor to the boardroom, needs to see decarbonization as part of their job and as part of the company's DNA. Training and upskilling are at the heart of this process. Only by continuously developing people's competencies can organizations adapt to new technologies, new policies, and new market realities. Finally, a holistic approach is essential. Energy efficiency should not be confined to individual systems or isolated projects. It must be integrated across all company processes and throughout the entire supply chain. When this happens, the impact goes far beyond energy savings. It drives innovation, resilience, and long-term sustainability. Alongside its technical and educational achievements, the the EnTRAINER project is also helping shape the policy discussion around industrial decarbonization. One of the recommendations we're advancing is the creation of a holistic legislative framework, effectively a net zero industry code, that merges existing regulations and best practices into one coherent structure. This would simplify compliance for companies and promote consistency across the EU. We also propose the introduction of digital product CO2 passports for industrial inputs and outputs. This would make it possible to trace carbon footprints throughout the value chain, improving transparency and helping industries make informed, low-carbon choices. Another priority is to expand funding and support schemes for industrial decarbonization. Many companies want to act but struggle to access financing or incentives. Simplifying funding mechanisms would make it easier to turn audit recommendations into real investments. We also recommend integrating industrial decarbonization targets into updates of the Energy Efficiency Directive (EED) to ensure that the industrial sector receives the attention it deserves within EU climate policy. Furthermore, establishing an EU Industrial Decarbonization Observatory could help monitor progress, share best practices, and provide data-driven insights for future policymaking. Finally, EnTRAINER emphasizes that corporate governance has a key role to play. Decarbonization should be reflected in board-level decisions, strategic planning, and performance evaluation. The core message is that the energy transition audit methodology works, but for systemic change, policy courage and cultural transformation are needed. Only when regulation, business culture, and innovation move in sync will Europe's industrial sector truly achieve its net zero ambitions. To wrap up, I want to thank everyone who has contributed to this journey,